All right, well, here we are. You are watching the Intermediate Algebra Final Exam Review Series. This is question number 45. I'm Joe Brownlee with Palm Beach State. Let's get to it. And the directions for number 45 are simply to solve this equation. All right, so 45. And the equation they give us to solve is radical x plus 7 plus 5 equals x. All right. Well, if I'm solving the equation, I know that I want to solve for my variable, which means I want the variable on one side, and then an equal sign, and then everything else. Hopefully a solution, a number of some sorts. But right now I have my variable on both sides of the equation, so I can't have that. And I probably am going to want to get rid of this radical sign, but before I can do that, I have to isolate my radical on one side of the equation. Well, right now I have my radical plus 5, so it's not isolated. So let's go ahead and subtract 5 from both sides. That way I have an isolated radical. And we get radical x plus 7 equals x minus 5. And to get rid of the radical sign, I'm going to square both sides. And on the left-hand side, when I square my radical, the radical goes away, and I'm left with whatever was originally under the radical sign, which in this case is x plus 7, equals, well, now I have x minus 5 squared. Well, what's it mean when we square something? Well, we write it out twice and multiply, don't we? So in this case, we have a binomial times a binomial. And by now, we've done enough of these. We know we're going to FOIL. So x times x, well, that gives me x squared. X times negative 5, well, that gives me negative 5x. Negative 5 times x gives me negative 5x. When I combine these two, because they're like terms, I get negative 10x. And then lastly, negative 5 times negative 5 is positive 25. Well, now that I've got a quadratic going on here, I'm going to want to set this equation equal to 0 and factor. So let's go ahead and subtract x from both sides. Let's go ahead and subtract 7 from both sides. And when I do, they cancel on the left, and I'm left with x squared minus negative 10x minus x is negative 11x. And 25 minus 7 is 18 equals 0. When I factor this, I'm looking for factors of 18 that add to give me negative 11. Well, that's going to be x minus 9, x minus 2, because negative 9 times negative 2 gives me positive 18, and negative 9 minus 2 gives me negative 11. And now if we set each of these factors equal to 0 and solve, we get x equals 9 and x equals 2. But I'm not quite finished yet, because I want to take each of these values of x, plug it back into my original equation, and test to see whether or not I get a true statement. Alright, so let's switch up the color so we can see it a little more easily. Alright, so let's go ahead and plug in a 9 for x and see what we get. If you have a calculator, I would go ahead and bring it out now. Alright, so I'm going to get radical 9 plus 7 plus 5. Well, originally I had just an x on the right-hand side of my equation, didn't I? So if I plugged in 9 for x on the left, well, it has to equal x on the right, and so I'm going to plug in 9. So let's see what happens when I do radical 9 plus 7 plus 5 gives me 9. And so this is 9 equals 9. Well, that's a true statement. All right. So I know at least so far I'm going to use x equals 9 as a solution. Well, let's see about x equals 2. Square root of 2 plus 7 and then plus 5 equals 2. Let's see. square root 2 plus 7 plus 5 equals 8. Uh-oh, so this is 8 equals 2. That is a false statement. And so I'm not going to use x equals 2 as a solution. I'm going to drop it. So in this case, the only solution to the equation is x equals 9, because it's the only time when I plug in x for 9 that I get a true statement. All right, well, this was question number 45. Hope you enjoyed our Dolphins colors going on here. This is Joe Brownlee with Palm Beach State. I hope to see you all at question number 46. Thanks for watching.